Hi, folks, and welcome to the Space and Climate Change talk that we're having here for Space Week. I'm joined by Francis McCarthy, the Education Officer here at Blackrock Castle Observatory, and Alan Giltonen, the Centre Manager and Head Astronomer at MTU's Blackrock Castle Observatory. How you doing, guys?
Good. It's
Good, very good.
Yeah. So, how do you feel about this topic today? Do you think it's an interesting one?
I think the fact that World Space Week has gone with this, what is really a pressing issue, is fabulous. The idea that World Space Week, which has been running for years, has a different theme every year. And to go with climate action and how space can let us know what we should be acting, that there is a climate concern, there's a climate issue, a climate crisis, all these words are used. And space can help us. It can help us figure out what's going on. It can help us decide where our energies need to be addressed. Of course, there's issues with going to space, and we can discuss that as well.
Yeah, I would agree. It's a very timely conversation to be had. Obviously through the World Space Week endeavor, but in general, it's been a hot topic for a number of years now, and there have been a few initiatives come online in the last couple of years in response to some of this, which is also great to see. But we are at a very important point in our exploration of the universe. But when it comes to putting things in space, when it comes to looking at us, looking at Earth from space, we are at a very important point in that path. So it's a very timely conversation.
And it's kind of exciting that it feels like a lot of the conversations we've had about major planet level issues in the past have been kind of after the fact when the damage has been done, such as when the chlorofluorocarbons were causing damage in the ozone layer. The cat was a little bit out of the bag before we start to tackle that particular problem. But exploring space, we're in many ways very much in our infancy and just starting to get to that point where it's becoming easier and something that we're doing more prolifically. So if we can have these conversations now, we can go out there in a more responsible manner and maybe mitigate any of the potential negative side effects that we might have seen if we'd gone out there a little bit more recklessly. But I think the more exciting aspect of where this kind of the center of this Venn diagram of space exploration and climate change exists is actually how space can teach us a lot about how we can maybe mitigate climate change here on Earth, or some of the impacts of it at least. Because when you look at something like the International Space Station, that is in itself a pretty closed system. I know we send up supplies and everything, but it's a self-contained system, very similar to the Earth in that regard. And they have to manage their resources accordingly. So it teaches us a lot about how to manage resources here on Earth. So Francis, can you think of some examples of ways that they do manage those resources on the International Space Station?
Well, this is something I have shared with teachers over the last few years, that the ISS is a closed system, but so is our planet. Our planet is a complete closed system. And some of the recycling methods which are used aboard the ISS have direct applications for us here. In fact, the very identical system that is used to get the water from your sweat, from your body, it's recycled and purified in situ aboard the ISS. And a similar setup was put into Morocco to be used for a school that wasn't connected to the grid system of water. So they were using solar panels to power the identical purification system that was used aboard the ISS. That's cool.
That is really cool. I guess the thing we can say about the ISS is we do send supplies up to it.
Yeah.
So the analog here that people have mentioned in the past is that maybe we could start looking for resources beyond our own planet and bringing them back, such as asteroid mining. So Al, do you think that that's a realistic prospect in the future, or is it still, technically possible, but still well beyond the realm of something that would be useful for us?
Well, there's a bit of truth to both those scenarios, Rob. So is it going to be technically possible? Yes, of course. We've already landed on some of these objects, so that's already a path in terms of technology that is reasonably well developed. It's not fully there yet, but it is reasonably well developed. Mining it and returning it has lots of pros and cons. You know, there's a so for example, there's a Mars return sample mission which has actually been put on the long finger at the moment by NASA. It's been cancelled on some level, but then brought back to life on other levels because it's purely funding based, whether that happens or not. But there's a lot of pros and cons as to whether you actually bring a sample back from a body outside of Earth. There is clearly some dangers to it on some level. The reality is bringing back a whole load of exotic materials, which we may have, or we might be in, let's say, short supply or limited supply here on Earth for the likes of battery development and whatnot. Yeah, I could see that happening, but we're probably 100 years, 50 years at least, if probably closer to 100 years away from that being an actual truth. The distances involved are just so large, getting things to and from there, having the resources. Some of the mining will be done on site. As you may or may not know, mining generally involves a processing element to it. So you generally don't use the raw material as is, you have to process it in some way. Whether that's going to be processed in situ and shipped back as a finished product, or whether it's going to be brought back in its raw format and polished and refined back on Earth is to be debated still. But either of those are going to be very lengthy processes. So is it going to be done? Probably at some point. Is it going to be used back on Earth? To a limited extent. I could see a bigger application for it being used for human exploration throughout our solar system, to be honest.
That is actually an interesting point, because it's something that I'd kind of noticed in the discussions about space exploration, is that when we get out there, it's obviously too expensive to be bringing materials from Earth to construct, we'll say, a lunar base, for instance. So if we go to the moon, we want to use local materials like lunar regolith. And that's something that's, in sustainable architecture here on Earth. They tend to encourage people, not to be shipping the finest wood from Scandinavia just because it looks nice, when you can get wood closer to home and reduce the carbon emissions associated with you building your home. Can you guys think of other examples, Francis, perhaps, of ways that we might make use of local materials if we were to go to the moon, for instance?
It's something that the European Space Agency is actively interested in, and has, in fact, an education resource called MoonCamp, which looks at what might you do to create something on the moon. The activities I've shared with teachers before look at designing a lunar base using Tinkercad to create a visualization, a representation, a 3D model of it. I think it's a while before we're going to be back at the moon to be building a lunar base, but I like the fact that students today can explore it as a theme, as a topic.
Yeah, and on that, if I may come in, so there are a number of groups who are looking to actually use material which is not too dissimilar to regolith as a 3D printing material. So the whole point would be to if you add in specific materials to the regolith, to basically create a better bonding system, a chemically better bonding system for them. You can then start to 3D print on the moon itself. So you basically, you can consider small but important building plants on the moon itself to create a more self-sustaining environment on surfaces like the moon and beyond, to be honest. But the likes of 3D printing and the materials needed to 3D print, I know we think of 3D printers and we think of the polymers and whatnot, the plastics associated with the PLAs and so on. But they're not the only mechanisms for 3D printing. So, if you're thinking of what's the next step in terms of materials and how one is going to build on surfaces like the moon, then think of different chemistry setups that you can 3D print on, and 3D print with in particular.
One of the cooler examples I saw mentioned was that there is water on the moon, and that if we can access it, because water is H2O, if you can split that water into its two component parts, the hydrogen and the oxygen, you've got one of the major elements of rocket fuel if you would then wanted to travel onto Mars, but you've also got oxygen, which is something that we obviously need to breathe if we were sending astronauts up there, and you would need oxygen for burning, a fuel if that was necessary as well. So it's kind of cool, all the really clever ways that people make do with limited access to resources. And another resource would have limited access to, obviously, in space is fossil fuels. We can't really burn fossil fuels on the International Space Station. So how do they get around that, guys?
Very, very large solar panels. That's why the ISS is such a fabulous object to look for in the night sky. When you catch it, you are catching the glint of those solar panels.
Yeah, and for future missions, if you can't produce or get the in terms of, so Francis has answered the ISS in terms of future missions which may involve large habitats, then you really only have two options. You're either looking at solar or nuclear. They're the two main options that are feasible at the minute. Because you're right, fossil fuel is just, it's not going to be an option.
Well, it seems like the transition to solar is becoming better every day, that it's starting to outpace a lot of the older forms of energy generation. So it's kind of cool that there's this whole joke that fusion energy, nuclear fusion, that the cleaner form of nuclear energy, that it's been 50 or 10 years away for about 50 years now. And people were saying a lot of the same things about solar energy. I remember even as I was growing up, and I'm not that old, that it was never going to fully replace fossil fuels, but we seem to be at that tipping point now where there is actually cheaper and cleaner energy being generated across the planet by this pretty cool technology, but still in many ways a very new technology. So it's an exciting development in terms of tackling things like climate change. But obviously, going out into space isn't the only reason that we're talking about this. We're living on a planet that's undergoing climate change right now, and space exploration can actually help us to see that, to track that, and to get a better idea of what that looks like and where we might need to mitigate it. And one of the ways that we're doing that is through Earth observation satellites. So can you guys maybe talk about some examples? Alan, I know you actually ran a hackathon a few years back, where some of the teams were looking at things like climate change and how they could track them. Can you give some examples of how they did that?
Yeah, absolutely. So as it currently stands, so the European system, the Copernicus, or the Sentinel, but the Copernicus system for the most part, is probably the best Earth observation system currently in use. It's a fantastic system which gives huge amounts of data. So if anyone wants to get involved in the data analysis side of Earth observation, there's always going to be data there for anyone, because we're currently producing crazy amounts of data from the Earth observation side of things. But going back to your query, Rob, so yeah, there are a number of examples of teams who used Copernicus data to do some analysis. It depended on the teams. The very nature of a hackathon is slightly different. But some of them were looking at a coastal erosion, for example. Some were looking at forestry. One team even were looking at how they were trying to get real-time or pseudo real-time like data on how busy beaches were at any one time, to try and come up with a tourism angle. So thinking outside the box type stuff, but still using the same data from that Copernicus satellite system, because it really does give a massively improved view and overview of the planet we live on. We can really detect massive amounts of pollutants, but the resulting implication that those pollutants have, which is very important. So, for example, we're all aware of the likes of forest fires and so on. these satellite systems, and it's a differentiator between the previous generation of satellites, of Earth observation satellites, the newer generation, the ones that are, have been launched in the last 5 years and so and are currently being designed, is they give us that real time, the actual real time feedback. So if you want to see where the forest fires are happening, and you want real time data, the current set of satellites will actually allow you to do that. Previous generations didn't do that. Whereas now we are using satellites for real-time monitoring of our climate and how we're impacting our climate. Forest fires are a result of impacting our climate. So we're looking at real-time data of how we're impacting our climate and how we can, in real time, combat it.
And forest fires have an additional side effect. So I'm aware as a Canadian that a fair bit of Canada is quite regularly burning now. The forest fire season has extended. Larger areas are being impacted. There is a knock-on to a forest fire, which I wasn't aware of. I came across it earlier today, that the soot of the forest fire then settles. And if it settles on a glacier, your glacier melts. The dark material increases the solar, it changes the characteristics of the surface. A darker surface, you're familiar, gets warmer on a sunny day. So we have this layering of issues that climate change is affecting the tree development, which is making them more susceptible to burning. And then the soot itself is then knock-on onto glaciers, which have been established and are melting at a faster rate. And it's interesting, Alan, you gave examples of the beach and the Sentinel data for this. Those are all places where people are. I like the fact that Earth observation allows us to look at the vast amount of this planet where people aren't. It lets us look at oceans. It lets us look at the poles. It lets us look at the majority of the land that people don't live in. People are very, very concentrated where we live. There's a large amount of the planet that we don't live on. But we need to be able to get the data from that area. And that's a lot easier to do from space than sending somebody there.
Absolutely. I mean, even in my background was in zoology. One of the ways that we can make some of these surveys easier is using space satellite imagery. For instance, you can count the number of penguins from space quite readily just based on the mess that they leave behind when they're present in large numbers. And it's not space data, but I've seen drones used to count orangutans, which is obviously much easier to do than to wander through the jungle, looking up through the dense canopy, trying to catch them. So it's amazing how this shift in perspective can make a job easier, more scalable. But from what I understand, it isn't as easy to get data from the poles, is it, or it's just more sparse than what we have for the equatorial regions?
Yeah, we were just discussing that. So if you're thinking about the planet, there is my inflatable globe. Here we have it. The weather satellites that we're used to, the meteosats, are centered over the equator in a geostationary orbit. They're spending 24 hours to circle once. The planet spins in 24 hours, so they stay over the same part of the planet. That's great if what you want to look at is a whole hemisphere, but obviously you don't get a lot of detail of the pole from your geostationary. So you have to look at a different type of orbit, which goes, in essence, up and down over the planet, generally running from north to south, south to north. These are the ones you might see at night moving across the sky when you go out to do some stargazing. But it's not particularly easy to go right over the pole. The forces that are on the satellite mean that orbit just isn't obtainable. It has to be at a little bit of an angle to one side. So if you look at a lot of polar data, there's a hole right over the pole because they just can't get the data there. Now, down in the South Pole, you've got people there. All right, so they can send your drones out and they can do that. There's not people living up in the North Pole because it's an ocean and you're dealing with ice and floating on ice. Cryosat is a European mission that's still running. Unbelievably, 13 years later, it's still going. And there's plans for a new space mission from from European Space Agency, an Arctic satellite, and that's going to be launched within 3 years. They've managed to get it going, and they're using the new technology, the new space technology. The entire satellite is the size of one of the instruments in an older satellite. So the miniaturization, the changing of the technology means that spacecraft can be designed faster, built cheaper because they're smaller. And that changes a huge amount in the type of data we can get and what we can do with it.
That's really cool. And in the Irish context, actually, this looking down thing, one example that struck me was peatland erosion. That it's kind of the biggest source of carbon that we have in Ireland. They're often called the Irish rainforests. I've seen examples of how these tracts of land get pulled back and get, you know, more and more damaged year on year. And I think it has helped a lot of conversations for people to be able to visualize the scale of it, because, you know, we're used to the imagery of, you know, one lad out there with his, I think it's called a skean, the knife that they used to cut up the bog for personal use.
Could be. I'm Canadian,
Yeah.
don't know.
But it's a completely different kettle of fish to what you're looking at on an industrial scale. And on an industrial scale, it does, you know, do quite a lot of damage to a lot of habitat. So being able to visualize that helps motivate people to act on it. And we are seeing that, you know, we're looking at moving away from relying on peat as our primary source of energy, and we see more investment in wind energy. Where I'm based right now, there's even just off the coast talks about generating a wind energy plant. So, you know, these images can help spur conversations about moving. But also,
well, Rob, they need to be more than conversations. We have a commitment to reduce our greenhouse gas emissions by 51% from 2018 levels by 2030. That's in 6 years' time. We have got to be measuring what we're doing so that we are fulfilling our requirements under international treaties. What the health of the planet requires us to change how we live and what we use.
absolutely. And that's why, as I mentioned earlier, it's kind of exciting when opportunities to get win-win scenarios pop up. So for instance, solar energy becoming actually cheaper now. It's no longer a case of we're using a less efficient method because it's cleaner. It's kind of no longer being such a difficult transition from, you know, coal-fired plants, etc., when you can actually get nice clean energy from solar. The other option that we might talk a bit about later, Francis, yourself and myself, is climate change and light pollution. You know, the opportunity to tackle the impacts of climate change and light pollution. There's a whole bunch of win-wins there that we'll come back to in just a moment. But there are obviously opportunities for new threats to emerge as well. And I saw a news piece recently suggesting that, for instance, satellites, as they burn up on re-entry, may be doing damage to the ozone layer. Now, it's a very, very provisional study. Nobody needs to be panicking just yet. It just warrants further investigation, and it's an interesting idea. But already we're looking at options for how we might be able to mitigate that impact if it turns out to be true on a larger scale. So Alan, can you give examples of other options that we have for satellites that might not do the same damage that these people are suggesting? I think it's aluminium in the satellites is the main.
It is. It is aluminium, and so some of the heavy elements are, but in particular, the aluminium, the conductive, some of the conductive elements as well, to be honest, are potentially posing some concerns for the ozone. And I've even seen a paper recently as well, Rob, which suggests that the amount of metallic debris we're leaving up there could potentially cause problems with the magnetosphere in due course. So very, very preliminary results, we'll call them, for both of those scenarios. But there is a case of, we have a history of underestimating the impact we can have on the planet. So, you know, this has happened previously. You know, previously it happened with the ozone. We're seeing it now with climate. You know, we didn't estimate correctly, or clearly underestimated the impact we would have on the planet by simply burning some fuel or releasing some CFCs. We didn't think of it on the larger scale. So we're now at that junction with space exploration. The good element is we are able to, thanks to a lot of the new technologies, we're in a better place to actually be a bit more proactive rather than reactive about this. So using the technology, even though we will complain about it, we can actually use it at the same time to negate some of the problems, to monitor them carefully and negate them where we can. So the use of different material types, for example, we'll be aware of the wooden satellite system that a Japanese entity is looking to launch. That's one example of thinking outside the box, of using different type of materials to launch and not just metals. So are there other composite materials which can and will be researched to be used as the casing, effectively the shell of the body of the satellite system that's been being launched. There is also so there's the zero debris approach, or the European Space Agency have developed this zero debris attitude in recently, and I think it got developed in about 2021 thereabouts, and was formally published in 2023. NASA are similarly following suit, and it is all about how the space exploration industry is impacting our planet, in particular in low Earth orbit and beyond. So there is a distinct move towards clean, keeping the debris clean, so cleaning up as we go along. So either bringing down defunct systems, or using materials that are not going to impact the planet in as negative a way as we currently would have been doing. A number of private entities are similarly looking at doing it, but it's going to be led by the likes of ESA and NASA in the first instance. And the reality is there are going to be companies, spin-off companies, that will, for example, instead of deorbiting a satellite system when it comes towards the end of its life, you'll reuse it. A lot of the parts on these systems are reusable. So if you can send up a satellite system that is effectively modular, so it's almost like a plug and play system, in 5 years' time, and some of the parts might become either obsolete or damaged, you can simply dock them in a mobile station in space, take out the the parts that are plug and play, take them all out and put them into a new satellite, and away you go. So a complete eco-friendly solution to actually having elements in space without having to launch and deorbit and relaunch and deorbit and relaunch, which is clearly not a sustainable or even from a cost point of view. It's not a cost beneficial way of doing it either. It's expensive to launch a satellite system. It's come down significantly, but it's still expensive. So it's a more cost-effective way of doing it, but it's definitely a more eco-friendly way of doing it. So there are a number of paths to ensuring that, we're in our early stages of this sector. Is Space 4.0 it's called. So it's kind of like an add-on to Industry 4.0, which we've all been living for the last few decades. So Space 4.0, it's in its very early stages, but we're at a point where we absolutely can make the right choices to make sure we minimize the impact we have.
It's funny, we have been talking about CFCs and how that was something that surprised us and kind of caught us off guard in terms of the damage it was doing to the ozone layer. But the good news is it's a problem that we actually came together and solved as a global community, which is kind of great, and it's a cause for hope. How are you guys feeling about the current crisis and the impact of greenhouse gases in particular and climate change, and the way that space empowers us to really understand the problem? Do you feel hopeful, or do you think there's still a lot of work to be done before we can start to relax a little bit?
Well, I'm always hopeful. It's my nature to always be hopeful. I think part of the issue is not the science. That's fairly clear. The climate variables can be measured. It's the people. It's the, are we taking the right actions? Do we recognize the problem? Does our own self-interest overtake the community that we live in and the world that we're on that needs to be minded and looked after? Have your checkup and take the correct actions. If you're told that you're doing something that's really bad for you, you'd normally stop. And I think humans are sometimes a little on the irrational side. And I would hope that, not to sound, grandmothery, but I would hope that my son's generation and their potential children's generation are looking at it in a different way, that they're not stuck in, no, I don't want to listen to the doctor. I can keep doing what I'm doing. That they're taking the health check and acting on it.
Yeah, I mean, I would be similarly optimistic. We have a significant amount of understanding of the damage that we're doing, and you mentioned the patching of the CFC. One of the core understanding that we found out about CFCs actually was through satellite to begin with. So it's always, sorry, it's not always. It's more recently played a part in a significant number of corrective actions on this planet, and it will continue to do so. The satellite information that we are gathering on a second, minute, hour, day, week, you name it, basis, that's all information that can be used, and we are all aware of artificial intelligence systems coming online. They're going to help because we can now process the data faster, more efficiently, with better, more accurate results. So, these are all things which are going to help. So it is down to us. Francis is absolutely correct. It is ultimately down to humans to take that corrective action. But with the advantage of having all the information available to us, we can start to make those informed decisions. But it will be up to us to make those decisions and see them through. There has been a history up until now about talking too much about climate action. A lot of talking about the damage we're doing and not enough talking about the solutions. Now we need to transition to the solutions part. And the solutions part means doing something. So, but I am
Alan,
very optimistic that we have come out of problems, many, many deep problems before. We will do it again.
Well, Alan, I'm looking even at the backdrop that you have in front of you, because as an example of a climate action, your picture is reminding me of an activity that we did quite recently called Click Polit. And I'm looking at the beautiful image behind you of our planet at night with the stars above it, and there's as many stars on the surface of the Earth from poorly chosen lighting. We're astronomers as well as space enthusiasts, and light pollution is something that we keep yammering on about. But it's a theme that we introduce to young people across Europe, and we allow them to debate what do they think should be done about light pollution, because it's light that is being produced on the ground and it's visible from space, which means in essence, you're taking your energy and firing it up. It's a waste. It's a complete waste. The amount of energy usage that is just literally wasted by lighting everything up at night is phenomenal. And so we asked students across Europe, did they think it was a problem? Who was it affecting? And they gave us some really interesting suggestions. And we asked them to look at the science, to look at the facts, to look at what's actually going on, and then discuss amongst themselves what was the most reasonable action to take. Some suggestions were proposed, but not agreed, like turn off all advertising boards. We kind of pointed out that companies have sometimes paid for them, so that was modified to turn off all advertising after 11 o'clock at night. There's no point in lighting up a huge billboard to sell us to people who aren't even there. All right. They looked at some interesting solutions with timings, with sensor driven, have lights on roads at a low level unless they detect something coming down the road, in which case the lights can turn on. In some countries in Europe, every road is lit up the full night long. At least in Ireland, we do have astronomy-friendly lights. There's been a lot of activity particularly in Cork, about new lighting in a new housing estate to take awareness of lighting solutions that don't light up the sky. So it was an interesting thing that there's a simple activity that I don't feel that, personal action should be the only thing that happens for climate action. But personal action can empower you to do more. It can empower you to put pressure on a system that is using too much. And you got to start somewhere. Here's the place.
It's an excellent example of what you mentioned about how it is now currently down to the people. Like, the science is no longer the issue. It's how do we implement the findings in an equitable way, and in a way that's sensible. And so, for instance, if you were to look at it in purely absolute values of what's the most efficient lighting, you'd only be using LED lights everywhere. And they are the most energy efficient by far, but they do have associated impacts such as causing light pollution and potentially interfering with the circadian rhythms of humans and animals. So that's an interesting case where, okay, maybe not the most optimal energy efficient way to do something is still the best way overall. And it's something we would definitely encourage students to consider, is that, there is no right answer. You're not trying to get to the correct answer and solve all the problems. You're trying to balance the needs of one aspect of society with the needs of another aspect of society in the most equitable way that solve as many problems as you can. So that's why I love the light pollution example so much, and everything that you're doing with the Click Polit is really cool. And we're going to be sharing some of those resources with anybody that's interested, along with this video. And I did mention that my favorite thing about the light pollution is that it's a win-win scenario, because it does benefit us to turn off the lights at night. It reduces the costs of turning off nobody benefits. Absolutely nobody benefits from sending lights into space.
Oh, the people who sell those nice pictures.
There you go. Yeah. Alan.
That's the
all Alan's
only
fault.
people I can think of.
Actually, it's funny. My colleague Danielle did a podcast where we discussed light pollution some time back, and we'll be sure to put a link to that in after the video as well. We discussed some of the other issues associated with light pollution. But the new acronym for talking about light pollution at night is Artificial Light at Night, or ALAN.
Alan.
And there you have it, Alan with the light pollution behind him.
Yeah, very, very, very appropriate. But you're right. I mean, these concerns are, whilst there are quite often very obvious solutions, sometimes when you dig a bit deeper, it is a bit more nuanced. So for example, you use the example of the LED light. On the surface of it, absolutely, it all makes perfect sense. One drawback with that, however, is, LED lighting is not natural to our eyesight. Our body isn't actually tuned to that frequency, or to only that frequency. So it is known that LED lighting can actually cause headaches if it's used under the wrong conditions. So that's one example. It's a case of, a solution can work the majority of time, but not all the time. So there has to be a multi-pronged approach to actually solving some of these difficulties and concerns that we have. It's not just a case of turning it all off. That's not going to work. As much as we would all like it, it's just not going to work, because the world still needs to go ahead, still needs to revolve. People in it still need to go about doing their jobs and enjoying their lives and so on. So it's not a case of simply turning it off. That's not how things are in reality. That's not how things are going to pan out. So we need to come up with an appropriate solution.
I think that's the problem perfectly stated right there, and that seems like a good place to wrap up the discussion. And we hope that you will take this discussion and bring it further, and talk to your friends, your family, people in the classroom about these issues, and in particular the light pollution issue through the Click Polit activities that Francis mentioned, which I said we'll share again. Alan, thank you very much for joining us today. Francis, always a pleasure. And I hope that you guys at home are getting ready for Space Week. And if you are doing anything, please tell us how you've used these resources. Tell us what you've got up to in your classroom, in your clubs, or just even in the family home. And check out spaceweek.ie to find other activities that are happening in your area. Thanks very much, folks.